Yes, Shana.
Hi.
So, when you substitute r plus 2 as 32, s plus
Yeah.
1 should be 1, right? Because if
Yeah.
you check this condition, if you substitute r plus 2 as 32 over here, 32 times s plus 1 is equal to 32. So s plus 1 would give you the result as 32 by 32, which is 1. So that is how you will obtain the value of s plus 1 as 1. Can you follow this?
Yeah.
Yep. So you're just substituting their factors here. So for 16, if you substitute 16, you will have 32 by 16, which will give you 2. If you substitute 8, 32 by 8 will give you 4. If you substitute 4, 32 by 4 will give you 8. If you substitute 2, 32 by 2 will give you 16. So and so on, it
Yeah.
goes on like that. So we'll have up to 1. Okay, so these two columns are done. For R and S, it's very simple. You just have to, for finding the value of R, you just have to subtract 2 from this column. If you do that, you will have 30, 14, 6, 2, 2 minus 2, 1 minus 2 will give you minus 1. Okay, similarly, you apply the same for S as well. 1 minus 1, 2 minus 1, 4 minus 1, 8 minus 1, 16
Yeah.
minus 1, 0 minus 1. Yes, very simple.
Yeah.
And for R plus 1, you just increase by value 1. For S plus 2, you just increase it by 2. Okay. And then you just have to multiply these for obtaining this column. Okay. You got it?
Yeah.
Okay. We'll move to the next case. And similarly, you're just doing the same for this condition as well. You just follow the same strategy. 64, 32, 16, 8, 4, 2, 1. Same substitution, blah, blah, blah. You will get this answer. Okay. Very simple explanation. These things are. So if you combine the results of all the three cases, the positive integers n satisfies the given conditions exactly when n is equal to 2 raised to the power 2, 5 raised to the power 3, P3, P4. So 2 raised to the power 2, 5 raised to the power 3. 2 raised to the power 2 is 4, 5 raised to the power 3 is 125, which would give you the result as 500. So it's 500 P3, P4. Okay. And for the second condition also, it's 2 part 2, 5 part 3, and P3 part 3. So again, you will have 500 P3 part 3. So this substitution, we are doing it from the condition. I hope you are able to follow it. I'll just show you where it is. Yeah, from here. From here. Okay. And also from here. Can you follow this?
Yeah.
We already knew that this P3, P4 not equal to 2 or 5. Similarly, for this also, the P3 is not equal to 2 or 5. And they said this n is lesser than or equal to 20,000, then either this 500 P3, P4 lesser than or equal to 20,000, which gives P3, P4 lesser than or equal to 40. What are you doing? Here you are just dividing both the sides by 500. Okay. So it's P3, P4
Yeah.
lesser than or equal to 20,000 by 500. So we ended up having 40 on your right answer. Yes. So we're
Yeah.
doing the same for the second condition as well. So we're going to have P3, P4 lesser than or equal to 40, P3 cube lesser than or equal to 40. So it remains to determine the number of pairs of primes P3, P4 that are not equal to 2 or 5 with product less than 40. Okay. And the number of primes P3 that are not equal to 2 or 5 whose cube is 40. Very simple. So you take any 2 prime number, but it shouldn't be 2 or 5. Okay. So try 3.
Yeah.
3 means you can go for 7 because 3 times 7 will give you 21, which is absolutely lesser than 40. You are allowed to take this possibility. So if you go to the next one, 3 into 11, 33. Yes, we can do that. It is also lesser than 40. If you try with 13, 3 into 13 will give you 13. Of course, it is also lesser than 40. Yes. So now you do have one, two, three possibilities. The order of P3 and P4 doesn't matter as switching the order gives the same value for n. We note as well that we cannot have both P3 and P4, at least 7, have their product at most 40. In the second case, the only possibility is P3 cube is equal to 3 cube. This means that there are 4 possible values of n satisfies the given condition. I don't get this part. 1 minute.
Okay.
How did you get 4 possible value? We cannot have both P3 and P4 at least 7 and have their product at most 40. What are they trying to say? At least 7. I mean, both at least 7 means like 7 into 7 will give you 49. So the most is 40. So you do have 3 possibilities. Okay. So what are the numbers you are having? You do have 3, you do have 7, you do have 11, you do have 13.
You have 32.
Sorry?
You have 32 too.
I can't hear you.
I think we have 32 too.
32 also. How?
Doesn't it say? Oh, never mind.
No, you can't get 32. 32 means 4 eighths are 32, right? You will not get. See, you should
Yeah.
use only, you're supposed to use only the pair of prime numbers, right?
Yeah.
So 3 into 7, 3 into 11, 3 into 13. So it's 3, 7, 14, 13. Yes, I think these are the only possible values. They are confusing here. That's it. Please check in your answer option. Do you have the answer as 4?
4.
The option A. In the
It
option A.
should say. It should say in the solutions what the
Sorry?
answer is.
Okay, it is given as answer A only. Where is the question? Yeah, it is 4 only. Yeah. It is
Oh,
only
okay.
these 4 numbers. 3, 7, 11, and 13. Yes. What they're trying to say here, if you substitute P3 as 7, like 7 cube cannot be lesser than 40, right? And 11 cube, this also fails. You can't put 11 cube as also lesser than 40. You can't use 13
Yeah.
cube also. Do you understand? You'd be only able to
Yeah.
use 3 cube because that would give you 27. Yes, that 27 is lesser than or equal to 40. So that is why they are explaining this. For P3, we
Yeah.
have taken 3. So P4 must be, like 7 or 11 or 13. They're not sure. Do you understand?
Yeah.
Yeah. This is very elaborated answer actually. Do you want me to summarize this?
Sure.
Sure. You want me to?
Yeah.
Okay.
Yeah.
Okay, I'll do it. All right. So in the beginning, we were only discussing the results based on the facts because they're saying that you would be having the positive devices answers as A1 plus 1, A2 plus 1, AK plus 1. So the very first factor, the very first fact is based on the fundamental theorem of arithmetic. So which is based on finding a factor tree. So they have taken the example of 1500 and they are elaborating this as a product of prime numbers. So which is 2 power 2, 3 power 1 and 5 power 3. So there is no other way of writing 1500 as a product of prime numbers. We do have only one way. And in the fact 2, they said n is a positive integer, which means that 1500. D is a positive integer, which is a divisor of n, like it could be 2 power 2 or 3 power 1 or 5 power 3. Then only possible prime factors of D are the prime factors of n. So you can only be able to divide this by 2, 3, 5. You cannot divide this by 7 or 11. So that's what they're trying to say here. The
Yeah.
fact 3, they're trying to say you can only divide these things by lesser than this or equal to that. It cannot go any larger power of this specific value. You can only divide 2 power 2 by 2 power 1 or 2 power 2. You can't use 2 power 3 or 2 power 4. That applies to 5 power 3 as well. For 3 power 1 as well. For 3 power 1, you can only divide it by 3. It can't go beyond 3 power 2 or 3 power 3 like that. Similarly for 5 power
Yeah.
3. So these are the three facts. And so now again we are going to the positive divisors of n, which is expanded as p power 1 a1, p2 power a2, and so on pk power ak. Okay, and also we have written the form of the devices as p1 b1 p2 b2 and pk bk. So you're just applying the condition, applying the fact 3 over here, and you are writing b1 is lesser than or equal to a1 and greater than or equal to 0 because it is a positive integer. And that applies to B2 also, which is 0 lesser than or equal to B2 lesser than or equal to A2. So from that, you can say it's A1 plus 1 because you're considering 0 also. So for B2, it's A2 plus 1, and for P3, it's A3 plus 1. So these are the devices. And over here, you have just taken the prime factorization for 2 and 5. It's 2 power r and 5 power s because in the question it is only asked for 2 power 2n and 5n. Okay. So when you are taking 2n, you are increasing this value. It becomes 2r plus 1 because you are considering 0 also. And for 5n, you are considering 0 also over here. So which is 5 power s plus 1. So in the question, it is given that 2n has 64 positive devices and 5n has 60 positive devices. So you're just equating them. And also, now we are going to express these two expressions by using common positive devices. You know the devices of 64 and 60, and from that you're finding the common thing, which leads to 1, 2, and 4. So for these three, you are developing three cases, case 1, case 2, and case 3. So from this, you are equating a part of a statement to case 1, case 2, and case 3. So that leads to equal to 4, equal to 2, and equal to 1. So you are substituting that value and you are simplifying it. You are getting some equations. And by using the algebraic elimination method, you are doing subtraction for finding the value of r and s. So that leads to a quadratic equation. So you have solved the quadratic equation for finding the value of r and s. So again, you are substituting these values over here. Over here, you're substituting the value of r and s here. So once you substituted, you got some conclusion from that. And again, you're going back to case 2. So when you go back to case 2, again, you are substituting this part at 2. And you are dividing the right side 64 by 2 and dividing the 60 by 2. That leads to 32 and 30. And you're drawing a table for this, trying to find the possibilities. So you are writing 32 and the factors as well, 16, 8, 4, 2, 1. So you're just substituting in the equation for finding the value of s plus 1. For r, s and all, you're just simplifying these, and you know how to do this. You just have to multiply these two results at last. So you're repeating the same for case 3 as well. You're just going to equate it to 1. So again, you are drawing the table for this case also. So combining these results would lead to these conditions. So you know what is 2 part 2 and 5 part 3. That will give you only 500. So if you divide both the sides by 500, you know the condition already, which is given in the question. The n is lesser than or equal to 20,000. So when you divide both the side by 500, you will get the result as P3, P4 less than or equal to 40 and P3 cube lesser than or equal to 40. So now you are going to determine the number of pairs of primes for P3, P4. So we already knew it is not equal to 2 or it is not equal to 5. So you have to go for another prime numbers. So you know the prime numbers 2, 3, 5, 7, 11, 13. It goes on like that. So you
Yeah.
know the condition you have P3 times P4, which means you have to multiply two prime numbers. So you are taking 3 into 7, 3 into 11, 3 into 30, right? So you are having four results from that. And for solving this condition, you're just substituting P3 value as 3 because that is only true. If you substitute any other value than 3, 7, 11, 13, that would fail this condition because they are all greater than 40. 7 cube is greater than 40, 11 cube is also greater than 40, 13 cube is also greater than 13, which is why they said you can only substitute P3 as 3 here. That's all, Shana. Do you understand this problem?
Yeah.
Okay. Okay, maybe we can stop here today. We will discuss the Gallio's paper in the next class. Will that be fine?
Okay.
Yeah.
Yeah.
Yes, Shana. Okay, Shana. Bye bye. Have a great weekend.
Bye. Have a great weekend.
Thank you.